Almost a decade after the 2010 Deepwater Horizon disaster,
There we go.
hundreds of scientists are assessing the impact of the largest offshore oil spill in U.S. history. What follows are some of their stories, intimate portraits of research, innovation, and discovery. On April 20th, 2010, the United States experienced the largest offshore oil spill in its history. To break up as much oil as possible, dispersants were sprayed onto oil slicks on the surface of the water, as well as directly into the escaping oil. The use of dispersants quickly caught the attention of the news media.
Deadly mix. Did the chemicals used to break up that oil in the Gulf do more harm than good?
Little is known about the effect of these chemicals applied in such great amounts.
The EPA insists dispersants are biodegradable, but many locals worry their community could become another love canal.
This is a question that is not easy to answer. We have started in 2012 knowing basically nothing about the behavior of oil in the deep sea. Now we at least know our unknowns, so we at least know what we don't know. And the question of dispersants is quite one of those unknowns.
One thing we do know, however, is dispersed oil is more toxic than crude oil to a variety of animals, including baby fishes. So you get rid of it quicker, but it perhaps has more toxic effect over a short duration. This is a very active area of dispute.
What we find is when dispersants are used, that there is a change in the aerosol size distribution. So these are changes in particles that could contain oil and dispersant material that are airborne and could potentially affect air quality both in the immediate vicinity of the spill, but also potentially be transported long distances.
I feel that some of the things that would have been done differently is that folks would have got out there and done a different kind of assessment of the area of the spill. I feel that folks may have been a little bit more tactile in how the dispersant was applied and where it was applied.
We're really relying on other investigators that are oil scientists that are helping us figure out these pathways, and with dispersants or without dispersants, what's more damaging when a bottlenose dolphin breathes that in or swallows that or eats it through contaminated prey.
Some of what we found suggests that for some organisms, not for all, but for some, dispersant plus oil is a very, very toxic mix. For other organisms, we found that the dispersant itself was actually more toxic than the oil. And for yet other organisms, the oil was the most serious threat. So this complex role of dispersant is one that the Gulf of Mexico Research Initiative has been unraveling, and we've learned a lot from that process.
We're now at a point where we've got to start synthesizing this information to make those predictions about what happens in the future.
Hopefully there will not be anything like this in the future, but because there is increase of exploration in deep waters, there is a chance that something like this happen in the future, and now we know that we have to rethink the idea of using toxic chemical dispersant at depth.
Today, the scientific community is working together to push the boundaries of what they've learned about oil spills and what still needs to be discovered.